Anyway, I'd like you to try these. Try these problems here. Number one, tell me the oxidation state of chlorine in all of the chlorate chloride series, and then see if you can do this half reactions and then these half reactions. All right. So see if you can do those. That'll be the only thing I'm going to review today, and then the rest of the time we're going to spend working on problems. See that? So with the oxidation state of chlorine and all those polyatomic ions, and then try to do the half reaction for the next two reactions. If you get stuck a little bit, I'm going to help you. That's true. And what's this one? Okay, yeah, that's right. Very good. It's okay if you get a little stuck because really the half reactions, the first time we did that was yesterday, not counting 10th grade. So if you get stuck, you'll be all right. Just try it and find out what it is that made you get stuck, and then we'll try to get over that bump. if you get stuck, don't worry about it. Just try to get through that and see what it is. Say, well, now I know what it would have been tomorrow that I would get stuck on. All right, let's stop for a minute. And Calvin, you were one of the first people I saw have this done. Can you tell me real quickly how you did all these? How did you do the first one?
Oxygen's always -2.
Except
When it's dioxide.
peroxide. And all right, you don't have any peroxides here.
So that gives you a -8 for oxygen. And you want to end up with a -1, so that means that Cl will be 7.
+7, that's great. How about this one?
Oxygen's again -2, which means you have a -6, which means that Cl is +5.
Very good. Next one?
Same thing, you get a -4, so then Cl is +3.
Okay, next one?
You get -2, so Cl is +1.
Oh, man, that's good. Okay, next. How about Jonah? How about this one? Just give me some oxidation states. I'll go right across here. We'll go lead, oxygen. What do you think any of these you're sure about?
Yeah, so that would be +2.
Because this is -2?
And carbon would be +3.
Okay, and that's kind of unusual. That's unusual for carbon to be +2. Go ahead.
And then light would be 0.
Yeah, because it's an element.
And then carbon would be +4.
How'd you know that?
Because it's opposite to oxygen.
Okay, all right, very good. All right, so who do you think got oxidized? Who, if you lose negative electrons, you become more positive. Who got oxidized?
Carbon,
Okay, what did it go from?
+2 to +4.
Now, how does something go from +2 and jump all the way up to +4? Add? Add, you mean? Or produce? Or, yeah, going to lose. So it's going to lose the 2 electrons, right? When you lose them, they're a product. So this turned into this and this. And so we always put products on the right-hand side like that. All right. All right. What about, and this is already balanced?
Yeah.
Okay, that was good news. All right. Now what about down here?
So light is going to be 2d2.
All right, lead was +2. And what did it jump down to?
0.
So it was reduced down to elemental lead. Okay. How do you do that? How do you go from +2 all the way down to 0? I see, gain them, right? And a gain of electrons means you're reduced. All right, now do these match? That's important. Yes. Okay. And how many total electrons were transferred? 2. Okay, good. One more, Jonah. Who was the oxidizing agent?
The light.
What is?
The light.
The oxidizing agent was who? The lead, yes. Okay, who was the reducing agent?
Carbon.
All right, okay, good. All right, and here's the the most difficult one. Who wants to try that? Even if you think you might have to stumble through it, who wants to try this last one? And then we'll get into groups after this. Carson, can you help me? Think you can do it? I'll help you. What if I help you?
So lead is +2, sulfur is -2,
Very good. Good start.
oxygen is -2.
Normally, but when it's only an oxygen is not combined with any other element, it's like the element oxygen. So those are zeros. Okay. Go ahead.
Lead is +2, oxygen is -2.
Okay.
Sulfur is -2, oxygen
Okay, so if oxygen, look right here, if oxygen is -2 and I have 2 of them, that'd be -4. So what's the sulfur have to be? +4. All right, now as we look through there, if you lose negative electrons, you become more positive. All right, Carson, who got more positive as it went from reactants to products?
Sulfur,
Okay, so sulfur went from -2 to what?
+4.
That's a big jump. It went from -2 all the way to what?
+4.
Wow. How in the world can you do that? How you can go from -2 all the way to +4?
By losing 6 electrons.
How many?
6.
Okay, now, here's the tricky part. Even though each sulfur had to do this, let's go back here and make the numbers make sense. Did you really start with only one of those?
I start with 2.
Okay, so I'm gonna put 2 there. And did you end up with only one of those?
2.
Okay, so then how many electrons here?
12.
Yes? Okay, there we go. All right, you're doing a great job. Now, tell me about who got reduced. If you gain negative electrons, you become more negative.
Oxygen.
Okay, and each oxygen did what?
It lost 2 electrons.
Now remember, if you gain electrons, you get reduced.
Yeah. Gain 2 electrons.
Okay, so oxygen started out with a 0. You told me it was 0. And it became oxygen that was what, -2? Okay, how do you do that? How do you go from 0 to -2?
Gain 2 electrons.
Yes. Okay, now we're going to go up and make the numbers make sense. Carson, how many oxygens did I actually start with, and what form were they in?
3 in every diatom.
Nice. Very good. That means 6, doesn't it?
Yeah.
So then I got to change that. If you said each one had to gain 2, then what do I put here now?
12.
Yes. And now what about this? Does that make sense that I had 6 oxygens here, but only 1 here?
Negative 6 is still 6.
And were they diatomic, or were they?
Just regular.
Say it again?
Straight oxygen.
Yeah, they were oxygen ions, weren't they? So how many?
6.
2 here and so 2 here and
6.
4 there. Yeah, 6. Does that make sense then?
Yeah.
And does this match? Ooh, okay, that was a hard one. What do you think? Does that seem a little easier than I did in 10th grade, do you think? A little bit. All right, I think I'm done with that. And what we're going to do the rest of the period is I'd like you to get to these black tables back here, maybe 4 people at a table. And if you'll get your homework out, make sure you have your answer sheets out. I'm going to visit every table. If you guys will help each other, I'll stop you. I did want to mention, I had somebody come out of school yesterday. I don't know why the author didn't emphasize this a little bit more, but if you're doing a problem, it's called parts per million. I had on the study guide, I had kind of circled that, and parts per million are in milligrams per liter. If it had been, they're assuming the liter is like 1,000 grams, so instead of grams per liter, it's really milligrams per liter. That comes out to be, anyway, so if you're looking for that one. All right, I'm done with that.